So you're working on problem number 3 on the homework, and you're starting to think that I gave you way too much work. And you are correct, if you're doing everything by hand. So let's take a look at this problem. We're trying to estimate the area under the curve and above the x-axis. The curve is y equal x squared, between x equals 1 and x equal 2. So the first part of the problem said, figure out an estimate using 10 lower rectangles and 10 upper rectangles. So if you're going to have 10 rectangles, let's use an arrow here, split up in this interval, each sub-interval will be 1/10 of a unit. So the total length of this interval, 2 minus 1, is 1, and then divided by 10. Then after that, we're supposed to do it for n equal 25 subintervals. So we would take this length, 2 minus 1, divided by 25 instead of divided by 10. All right, so that's the start. Now each rectangle is going to be the width of the subinterval times the height. For the lower rectangles, the height will be the left side, the left x value of your subinterval. When I evaluate the function at 1, that's going to be lower than if I evaluate it at 1.1. And then on the interval from 1.1 to 1.2, it's going to be lower if I evaluate the function at 1.1, etc., etc. So each rectangle will have an area of the width of the rectangle times the height of the function. And if you factor out the width, this is what we're looking at. And we'll end at f at 1.9 because the last subinterval goes from 1.9 to 2. So for the lower, we're going to choose 1.9. Now when you're doing the upper rectangles, it's just the opposite. Instead of the left side of the subinterval, we'll be using the right side because we'll get a higher value. And that just happens because this function is increasing over that interval. If it was decreasing over the interval, it would be the opposite. The lower would be using the right side of the subinterval, and the upper would be using the left side of the subinterval. All right, so now we're at this stage, and now we have to calculate each of these values. So we need to evaluate our function at 1, and then at 1.1, and then at 1.2, all the way to 1.9, and then we want to add all those values up. And that's a lot of work if we do it by hand. So maybe a calculator would save us some work. So I'm going to go to y equal, and I'm going to put in x squared. That's my function. Don't even need to look at the graph. I know what it looks like. And now I want to figure out what's f of 1, what's f of 2. So I could punch all those in individually, but that's still a lot of work. And what am I going to do when I get to 25 subintervals? Not even to mention, how about 50 or 100 or 500 subintervals? So there's a function on the calculator. It's in the list menu. You can get that by pressing second stat. And if you go over to the ops submenu, number 5, sequence, creates a sequence for you. So my expression is just going to be x, the variable is x. I'm going to start at 1. I'm going to end at 1.9. And my step is going to be 0.1. So that's when I have 10 rectangles. Enter. So you can see the sequence command from the home screen now. And when I press enter, it's going to create a sequence of all those values. And those are the values in the parentheses for each function in the green. So that's great that I have all those values and I didn't have to type them all in. But now what I need to do is take each of those values and plug them into our function. Well, once again, we can do that pretty easily. So I'm going to call up the y1 function. So second trace, alpha trace, and number 1 is y1. And I want to evaluate, now if I just wanted to plug in a number like 5, it would evaluate my function at 5. But I actually want to plug in all the numbers in that sequence. So I want to press alpha trace y1, put a parenthesis, and then I want to put that sequence in there. There's the sequence. Right there. Close it out. So now what that's going to do is take each number independently from that sequence, plug it into y1 and give you a value. So I'm going to wind up getting 10 values. 1, 1.21, 1.44, those are the values for f of 1, f of 1.1, f of 1.2, etc., all the way to f of 1.9. If I hit the right arrow key, you can see it'll scroll through that list for you all the way to the end. And we know the last term is 3.61, because 19 squared is 361. All right, so now I have all those values, but I need to add all those values up. Well, there's another command which will add everything up, and that's in the same list menu. So I'm going to press second, stat. This time, though, I'm going to go over to the math submenu, and coincidentally, also number 5, sum. And then I'm going to put in the sum from that list. There we go. And it adds up all the numbers in that list that we created, 21.85. Now remember, I still haven't multiplied. That's everything that's in the green brackets. Now I need to multiply by the width of each rectangle, which is 0.1. And I finally get my answer. So the 10 lower rectangles have a total area of 2.185. Now that seems like a lot of work. Maybe we can streamline that. So now I'm looking at this green calculation, and I'm going to do 2 minus 1 is 1 divided by 10. So 1/10, 0.1, that's the width of each rectangle, times, what I want to do is sum up, so I'm going to call that second stat, go over to the math submenu, number 5. I want to sum up all the y values, alpha, trace, y1, parenthesis, those sequence of numbers, back to the list menu, second stat, this time over to operations, number 5, from 1 to 1.9 by 0.1, paste, close out all my other parentheses, and I get that answer, 2.185. So I did all of that in one step. Now, how do I have to change that for the upper? Well, the 0.1 stays the same. I'm still summing up all the y1 values. The only thing that's going to change is my sequence. Second, enter. This time my sequence is going to start not at 1, but 1.1. And it's not going to end at 1.9. It's going to end at 2, but it still goes by 0.1. And so now I've already done the purple calculation for the 10 upper rectangles. Now I need to go and do that for 25 rectangles, and then do it for 50, and then 100, and then 500. Well, then now that seems like a lot of work. So maybe we can streamline all of this. Let's use a variable w. So let me take 0.1 store, and then alpha w. That's the width of each of my rectangles. Now let me punch in that calculation using w. So on any of the calculations, w is the width of the rectangle. So I'm going to do alpha w, and now I want to multiply that by the sum, second stat, over to math, number 5, the sum of all the y values, alpha, trace, y1, all the y values from the sequence, second stat again, this time ops, number 5. My expression is x, my variable is x. Now, this time I'm going to start, now I'm just doing the lowers. So for any width for lowers, 25 rectangles, 50, 100, 500 rectangles. So I'm going to start at 1. Now where am I going to end? Well, if there were 10 rectangles, I end at 1.9. But what if there's 25 rectangles? Now the width of each rectangle is going to be 1 over 25, or 0.04. So now I'm going to end at 1.96, and then that's going to change again. So I don't want to put a fixed number in there. It's just going to be 2 minus the width of each rectangle, 2 minus w. And what is my steps going to be? Well, it's the width of the rectangle again. So let me clear that, and let me just put w in there. So now I'm going to create a sequence starting at 1 and going up to 2 minus the width of my rectangle. So that's the left side of the last subinterval. And I'm going to go by steps of w, which is the width of each subinterval. And that sequence, I'm going to send all those numbers to y1 and get all the output y values, and then I'm going to sum all those up. Let's close that out, let's close that out, and then it'll multiply by the width of each rectangle, and I get 2.185. And that's because I put 0.1 in W. So now if I put 1 divided by 25 and store that into W, and then I recall, second enter, or you could up arrow and call it back. Now I'm going to do the same calculation again, but this time it's for 25 rectangles. And if I want to do 50 rectangles, the width of the interval from 1 to 2 is 1, divided by 50 rectangles. Let's store that into W. And then let's call up that calculation again. And now I have the sum of the area of 50 rectangles. So you can see 2.185, 2.27, 2.30, and my answers should be getting closer and closer to the exact area under that curve between 1 and 2 for y equal x squared. And then you can make the adjustment, as I mentioned earlier, for the upper rectangles, and then go through each of the n values for the upper rectangles. Hopefully this helps and saves you a little bit of work.